So in this case, we are going to determining intensity of UDL W, in which case we are given the ISMB 400. So for that, go into the steel table, page number 12, ISMB 400. You can find all these properties here. So copy paste all the properties, and here what we need is main this H1, B, and TF for section selection. TF, which in this case B here is 140, TF is 16, and the H1 is 334.4. So that's what you need for sectional selection. Using table number 2 from IS code, which is at page number 18, you can see. So what you need is roll steel section. The formula are given B by TF. So B equals BF, breadth of flange divided by 2, and TF, thickness of flange. And this, if it's the range of 9.4 less than 9.4, then plastic, compact, semi-compact. And the formula for the web, this was for the flange. For the depth, it is D by TW. D here is H1, and if it's within 84 epsilon, which is equals 1, this epsilon here, 84 epsilon is equals 1, then it is plastic. So in this our case, 140 divided by 2 into TF, it is range of 9.4, it is plastic, flange plastic. Same for wave, it is plastic as well. This wave and flange is plastic, or ZP will be 1. So our case here, it is laterally unsupported. In case of laterally unsupported, go to IS code, page number 54, you can find the laterally unsupported here. You are given all the formulas. MD equals BB into ZP into FBD. So here ZP is 1, no wait, BB is 1 for plastic and compact section. In our case it will be 1, and for semi-compact ZD by ZP. So here we have to apply all of these formulas, but I am going to teaching you an easy trick that you don't have to go with all of these big formulas. And the trick is, first we already know the BB, we have to calculate MD, we know the ZP. So for the ZP, ZEZ into 1.5 equals ZP. You can find the formula here, the 1.149 into ZEZ equals ZPZ. And here is first thing, go to the table number 14 of IS code. So the table number 14, and the page number here is not given, but it's after 54 page number. Next page, if you just open, then you will find table number 14. So here what you need is KL upon R and H by TF. So KL upon R is, first, K is effective length 5000 as we are given, span effective span 5000, and R radius is given RYY 28.2, and as for the age, it is total height, which is ISMB 400, so 400, thickness of flange 16, so you get 25 as H by TF, and KL upon R 117.7.3. So what you need to do right now is go to the table number 14, go for the 25 H by TF ratio as the 25, as you can see, and upper KL upon R ratio is 177, meaning it is between 180 and 170. From this we get the value H by TF as 25. So 25 ratio here, and our value what between 170 and 180. So we get these two values. If you just draw this line here, we can see we get the value of 136.7 and 127.1, and these are the values that are given. So now what you have to do is, there is a formula what I am going to teaching you, a trick that you can use for interpolation. First, mod 3, 2, and then first what values are known. We know the value of 170, we know the value of 180, and we also know their values in H by TF. So put them. Now AC, now what you need to do is, you want to find the value as 177.3. So what you want, shift 1 5 5 equal, we get the value 129.69, which is 129.7 if you take it approximately. Now what you need to do is table number 13A. Go to the table number 13A in IS code, which is about, it is after page number 54. From there you can find the Fy. If you don't have Fy given, just assume it as 250. So we assume it as 250. So from there, just drawing a line, and our FCR here calculated as 129.7. So meaning it will be between range of 150 and 100. So this value and this value is what we needed, between this range. So 106.8 and 77.3, that's what we need to put for 150 days, for 100 days. And what you want to find at is 129.7. Use the same trick of the interpolation and you will get the value of FBD. I can show you again. You have to press equal here. Equal, then after done, another equal, then AC. This is the value you want to finding at. Shift 1 5 5 and calculate. We get the 93.66, which here is just a printing mistake here. If you use the formula, you get this value as not as accurate as the calculator, and after done, use the mode 1 to go back to the normal calculator. Now what we need is MD. We find the FBD. Here the formula FBD, we know the ZP, BB. Now what you need to do is find the MD. We calculated the MD here. If you just do this calculation, you get the MD. M equals WL square by 8. This is the formula of M. So using this equation, what we need to do here is, there is another printing mistake in this book. It is 111.53 and not 1226.9. If you just put these values, you get the answer 35.68. So now the shape UDL, this was the W, but for the shape UDL, the UDL W minus this 61.6, it's the weight of ISMB 400, which is 61.6 kg per meter, into 10 raised to minus 2. It is always going to be, no matter what section is, into 5 is the effective span. This is in minus, divided by 1.5, we get 23.38 kilonewton meter. Now what we need is, we also have to check for serviceability, as we have shown. Check for serviceability. Now what we need is serviceability. What does serviceability means? Is checking the deflection. Deflection is delta limiting, which is span divided by 3000. Span is 5000, span divided by 300. So calculate this and you will get this answer. Now working UDL. So as for working UDL, at the 0 plus 0.616, you can skip this step if you want in exam, and we get this W here as 24, L 5000 in mm, and E is always 2 into 10 raised to 5. It will always be the same in Newton, and I is what we have find it from steel table, IZZ. You can see it here. So put all this in calculator and you'll get this value 0.95 mm, which is less than delta limiting, meaning allowable deflection, which was 16.67 mm is what the deflection allowable was. Our deflection is way less, so hence safe.